Imagine the Earth, not as the cradle of humanity we know, but as a vast, ancient vault of forgotten whispers. Picture a world where towering spires of crystal and light pierced the skies millions of years before our ancestors first kindled fire. Beings of intellect and ambition, perhaps scaled or tentacled, harnessing the fury of atoms and the rhythm of stars, only to fade into the dust of epochs. What if we are not the first? What if the ground beneath our feet holds the echoes of a civilization that rose, reigned, and vanished long before the dinosaurs claimed the land? This is the Silurian hypothesis, a scientific enigma that beckons us to question the solitude of our species in the grand timeline of our planet. As the camera drifts over mist-shrouded mountains and endless oceans, consider the immensity of deep time. Our human story spans a mere 300,000 years, a fleeting breath in the 4.5 billion year saga of Earth. Yet, complex life has pulsed through its veins for over 500 million years, evolving from simple cells in primordial seas to intricate webs of existence. Scientists like Gavin Schmidt from NASA and Adam Frank, an astrophysicist at the University of Rochester, posed this haunting query in 2018. Could an industrial society have flourished here eons ago, leaving traces so faint that we've overlooked them? They named it after the Silurian period, around 430 million years past, not as a claim of discovery, but as a lens to examine how time devours evidence. Imagine that world continents adrift on molten currents, forests of fern like giants swaying under alien constellations. In this setup, the stakes are cosmic. Our sense of uniqueness hangs in the balance, forcing us to confront the possibility that we are but echoes in a chorus of lost worlds. Delving into the mystery, we must first understand the relentless architect of oblivion, Earth's own geology. Plate tectonics, the slow dance of continental plates, subducts ancient seabeds into the mantle, recycling rock like a cosmic forge. Erosion carves away mountains, rivers redistribute sediments, and ice ages scour the surface clean. Over millions of years, even the mightiest structures would crumble to powder, their materials scattered and reformed. Our own industrial age, barely 200 years old, might leave only whispers in the strata after 100 million years. Schmidt and Frank suggest we look not for ruins or artifacts, those would be pulverized, but for subtle geochemical scars, fingerprints of intelligence etched into the planet's chemistry. Visualize ancient sediments layered like pages in an eternal book, each telling tales of carbon cycles and atmospheric shifts. One key signature could be anomalies in carbon isotopes. Today, our burning of fossil fuels releases lighter carbon-12, skewing the ratio in the air and oceans, a phenomenon called the Seuss effect. If a pre-human society did the same, mining ancient organics for energy, we might detect sudden dips in carbon-13 in rock layers from, say, the Devonian era. But nature mimics this too. Volcanic eruptions or methane releases from thawing permafrost can create similar excursions, as seen in the Paleocene-Eocene thermal maximum 56 million years ago, when temperatures spiked and oceans acidified. The deeper mystery lies in distinguishing artifice from accident. Would a cluster of signals, perhaps alongside spikes in rare metals like platinum or osmium, point to mining operations rather than asteroid impacts? Ponder the persistence of synthetics. Our plastics, those indestructible polymers, fragment into microparticles that infiltrate every corner of the globe, from mountaintops to ocean trenches. In low oxygen sediments, they could endure for millions of years, forming anomalous layers in the geological record. Imagine core samples from Antarctic ice or deep-sea mud revealing chains of carbon unmatchable to natural biology evidence of engineered materials. Or consider transuranic elements, born in nuclear reactors, plutonium-244, with a half-life of 80 million years, has no natural source on Earth except rare cosmic events. A spike in such isotopes could whisper of forgotten atomic power, buried in strata predating our kind. Yet, the emotional wonder arises from the silence despite searches in oceanic anoxic events, those black shale layers from crises like the end Permian extinction 252 million years ago. No such conclusive cluster has emerged. Each question peels back another layer, revealing not answers, but the awe-inspiring vastness of what we don't know. As we navigate these shadowy depths, the hypothesis invites us to re-examine familiar cataclysms through a new prism. Take the late Devonian extinction, around 375 million years ago, when marine life plummeted amid black shales and anoxic oceans. Was it solely volcanic activity from the villi traps? Or could industrial pollution have amplified the chaos? Nitrogen isotopes tell of disrupted cycles. Much like our fertilizers today overload rivers, creating dead zones. A pre-human era of agriculture might have accelerated erosion, flooding sediments with unusual mineral ratios, strontium or osmium spikes that echo our own Anthropocene. The human-marked geological epoch. But here's the poetic twist: these signals blur with natural hypothermals, periods of rapid warming that mirror climate change. The Eocene layers of mysterious origin, with their metal enrichments and isotopic oddities, tease at possibilities without confirmation. It's a dance of shadows, where science illuminates just enough to heighten the intrigue, leaving us emotionally tethered to the unknown. Before we step further into the unknown, take a moment to subscribe to Future Lens so you and I can keep exploring worlds beyond time, space, and imagination. Together, now, expanding the canvas, let's envision the beings who might have walked this path before us. Perhaps they emerged from the seas, intelligent cephalopods with minds like liquid lightning, their tentacles forging tools from coral and obsidian, or reptilian descendants of early tetrapods, scales shimmering under a younger sun, building networks across Pangaea before it fractured. Their society could have mirrored ours, a spark of curiosity, leading to mastery over fire. Then steam, electricity, and beyond. But with advancement comes peril. Unchecked energy use might have thickened their atmosphere with greenhouse gases, triggering runaway warming that acidified oceans and withered lands. Asteroids or supervolcanoes could have delivered the final blow. Or perhaps internal strife, wars amplified by technology, sealed their fate. The tension builds as we consider the cycle, their downfall burying organic matter in anoxic depths, farming the very fossil fuels we now extract, unknowingly inheriting their legacy. Deeper cosmic questions arise. If such a civilization existed, it reshapes our view of life's tenacity. In astrobiology, the Drake equation estimates the number of communicative societies in the galaxy, factoring in the fraction of planets where intelligence evolves. If Earth hosted multiple rises, that fraction swells, suggesting the universe teems with minds. Yet, the hidden truth might be sustainability. A long-lived civilization would minimize its footprint, leaving even fainter traces. Imagine their observatories piercing the veil of space, pondering exoplanets as we do now, only to succumb to the same hubris or misfortune. This scenario unfolds visually in our minds: crumbling metropolises swallowed by rising seas, skies choked with haze, species vanishing in waves. The awe intensifies as we realize our own era might be just as ephemeral. Our plastics and isotopes destined to puzzle future intelligences. Pushing further, consider the implications for our future. If pre-humans altered the climate, could subtle echoes linger in today's biosphere? Anomalies like the Franceville Basin's natural nuclear reactors from 2 billion years ago hint at how rare events mimic industry. But what if some isotopic quirks in ancient Oz stem from artificial fission? The hypothesis urges us to scrutinize past extinctions anew: the end Carboniferous rainforest collapse, with its oxygen dips and cooling, as a cautionary tale of ecological overreach. Tension mounts with the paradox advanced societies might self-destruct quickly, or evolve beyond material scars, ascending to forms we can't detect. This opens doors to profound possibilities, shadow biospheres, alternative life forms coexisting undetected, or cycles of abiogenesis where life reboots after global resets. In this visual tapestry, Earth emerges as a living archive. Its layers are palimpsest of rises and falls. We see glaciers grinding ancient cities to silt, oceans entombing reactors in mud, winds scattering synthetic ghosts across continents. The emotional core lies in our shared fragility, humanity, as a brief flare in the darkness, yet capable of learning from phantoms. As we probe exoplanets with telescopes like James Webb, detecting biosignatures in distant atmospheres, the Silurian lens reminds us to look inward too. What hidden truths does our world conceal? And how might we ensure our story endures longer than theirs? Slowing now, as the narrative crests toward reflection, we confront our place in this eternal weave. Humanity stands at the threshold, our innovations a double-edged sword that could etch lasting beauty or hasten erasure. The universe, vast and indifferent, may harbor countless such tales, worlds where intelligences bloom and wither like cosmic flowers. In the quiet expanse of time, we are not alone in our wondering. Perhaps those who came before gazed at the same Milky Way, dreaming of connections beyond their horizon. This hypothesis, rooted in science's humble quest, evokes a deep humility, urging us to steward our planet with wisdom born of imagined predecessors. And in that realization lies the goosebump truth: we may be echoes of forgotten symphonies, but our notes can resonate eternally if we choose harmony over hubris. For in the silence of the stones, the earth whispers, "You are not the first, but you could be the wisest."